Hello students, welcome to another session. Today we are going to take the physics test NEET 63 and we are going to do this analysis. I've just solved it. Paper is not that tough. 2 questions can be regarded as tough. 24 were medium, 19 were easy. Question number 44 has a problem there. They have given the speed 300 in the question and solved using 330. For 300 no option is matching. Overall it was an irregular paper. It again not a very easy, but it can be called as easy, not as easy as I can say the 1 or 2 days before paper, but it's still I can say for a good student or average greater than average 135 plus should be there, and for a very good student again 165 plus sort of paper is there because all questions are regular that you have done. So let's see what is in the paper. Let's start with the first one. The momentum of photon having frequency this. So what we know, the momentum is E by C for a photon, which is h nu by C. H is 6.63 into 10 to the power minus 34 in SI units. Nu is 1.5 into 10 to the power 13, and this is, you know, is 3 into 10 to the power 8. So this is 2 and this is 3.315 into 34 and 13, that is 21, and 8, that is 29. So 10 to the power minus 29 kg meter per second, that is the SI unit, and option A is the appropriate one. So simple formula putting. Next, total energy of electron in the second orbit. So we know E2 would be, E2 you know is equal to minus 13.6 upon 2 square, so that comes out as minus 3.4 eV. You remember this value. Second, third, block of body of mass m goes with speed v, collides elastically, okay, with same mass m which was at rest. After collision, first goes at an angle theta to the initial direction and a speed 1/3. The speed of the second block is. So what we have, this was going with velocity v, initial one was at rest. After collision, it goes with v by 3 at an angle theta, so it would go with, let's say, with v2. So what we can say, because it is elastic, so initial kinetic energy only one block had. Finally half m, this speed become v by 3, and let's say that speed is v2. Now this m by 2 I can cancel. So v square minus v square by 9 is equal to v2 square. So v2 square comes out as 8v square by 9. So v2 would be 2 root 2v by 3. So you can do this. This is question number 3 that we have done right now. Now the fourth one. Solid cube of AJ is molten and molded into 8 identical small solid cubes and are placed on one another on a straight line, with the edge of the bottom cube on the same horizontal plane on which big cube was placed. Then the vertical shift in the CM. So same question, we did some test before. Let's assume this was the bigger cube, and let's say I am seeing the front view. So its CM would be at this height. This is height is a by 2. Now it is molten, so its volume is a cube. Now 8 small cubes are made, so let's say their edge length be a dash, so that is 8 a dash cube, which implies a dash is a by 2. Now you have placed them one another, 1 2 3, let me draw slightly bigger because it's a by 2. So this is first, this is second, and this till it would be 8th one. So clearly the CM will be, if a by 2, 3 by 2, if I make them, this would be at the 4th one. I can say this is the 3rd, 4th. This is going to be the height of the CM, the midpoint, and this midpoint would be at the height 2a. You can make it out that it would be the midpoint 2a. So initially it was a by 2, finally it is at 2a, so the shift would be 2a minus a by 2. It comes out to be 3a by 2. You can make it out. Option A, we did it before also. Next, the 5th one. Now the next one, 5th. With what minimum speed should a small ball should be pushed inside a smooth vertical tube from a height h so that it may reach the top of the cube? Because it is tube, there is no risk of losing the contact. So simply I can say, at this point, if I remember the condition, this u minimum should be equal to root 4 gr, or you can write this at the speed at the topmost point is 0, whatever you wish. So if I do from here, so from here to here, what is the change in the height? This is the CM, this is the CM. So the CM goes by h minus r. So what I can have, this minimum speed square 4gr would be equal to initial v square. Here this would be initial and this would be final. I am writing energy conservation between these two because the normal forces are normal to velocity. They won't change they won't do any work basically. V square plus 2gh, and h is h minus r, not h plus r. So here it would be h minus r I can write. So now what we can have now, and h minus, sorry, it is h, the height is the radius of that tube is given as negligible, so that is root 2 gh. So from here v square comes out as 4gr minus 2gh. So what we have, 2g common, 2r minus h under root, that is the v that should be given. So what I am getting option D. Now next, a mass attached to one end of a string crosses topmost point on vertical circle with critical speed. That means you know that very critical is root gr. At centripetal acceleration when string becomes horizontal. So if at the topmost point this was vc, at horizontal point this would be, let's say, v. So what I can write, vc square would be v square minus 2gr. So v would be, from here comes out to be root 3gr. So the tension is the centripetal force providing element only. So T would be equal to mv square by r, that is m into 3gr by r. This r and r goes, this becomes 3mg. So the centripetal acceleration would be 3g. You can go for option B. Next, condenser of capacitance C is fully charged by a 200 volt supply. It is then discharged through a small coil of resistance wire embedded by a thermally insulating block of this specific heat and mass. If the temperature rises by 0.4, the value of C is simply energy conversion. That energy of the condenser goes in increasing the energy. That means half CV square goes into ms delta T. So the value of C would be 2 ms delta T by V square. So what is M? 0.1 kg I can write. S is 250, it is in SI units, delta T is 0.4 and V square is 200 into 200. So it's better write it as 200 into 200. So this is 5 by 4, this is 0.1, this is 200, this is 100. So what we have 5 into 10 to the power minus 4, I suppose, that is 500 microfarad. That is the value of the capacitance that I am getting from this data. Option D. Next, in a potentiometer experiment, the null point is obtained at a particular point for a cell on a potential wire x meter, potentiometer wire x centimeter long. If the length of the potentiometer wire is increased without changing the cell, so if you increase the potentiometer wire length, x will decrease, and therefore the balancing potential XL, x has decreased, so therefore L has to be increased. So L will increase. That's an easy one. Next, a uniform magnetic field of induction B is confined in a cylindrical region of the radius r. If the field increases at this rate, then the intensity of the electric field induced at a point P distant r from the axis. So here, what you know, here the electric field, if I write in the inside point, if you remember, induced field is written as r by 2 dB by dt, if you remember. So it is r by 2 dB by dt, means that is alpha. So therefore the force would be what it is, then the intensity of the field. Okay, if you are just asked the intensity of the field, that would be equals to alpha r by 2. Go for option C. So here you need to remember that induced electric field expression inside point is this much, E is r by 2 dB by dt. Next, two coils A and B have a coefficient of mutual inductance 2 Henry. The magnetic flux passing through coil A changes by 4 Weber in 10 seconds due to the change in current in B. Then, okay, so flux through coil A changes by 4 due to change in current B. Then the change in current B would be, so what we can say, flux would be equal to, what I write, flux is equal to Mi. So what I can write, that di by dt, I can write it as 1 by m into d phi by dt, or di you can write in the same time, di I can write it as, you can write it as, or delta I, you can say delta I, better word would be like this, delta phi by m. So delta phi is what, 4 Weber and m is 2. So 4 by 2 means the current will change by 2 ampere. So change in current would be 2 ampere in this time interval. Whatever be the time interval, we will go for option C. Next, two large oppositely charged insulated plates have a uniform magnetic field between them. The distance between, okay, uniform electric field, sorry, not magnetic field. The distance between the plate is increased by a small amount. Okay, so what we have, they are already charged and now you increase the separation. So you know this field in between depends only on the Q, not on D. So Q, the field will still remain the same. So electric field strength decreases. First statement I am pretty sure it is false. You have to ask the correct one. So this is false. The force of attraction, that will also remain same because the field is same, so attraction force will remain same. The potential difference, because electric field is same and gap has increases, so delta V is ED. E is same but D has increased, so potential difference will increase. So only correct statement is the third one. Go for option C. Next. 3 concentric metallic shells of radius r2, r3 are given q1, q2, q3 respectively. It is found that the surface charge density on the outer surfaces are equal, then the ratio of the charges given to them. So if you have these 3 concentric shells like this is the first, this is the second, and this is the third. If you give it q1 and if you give it q2, because of the induction of minus q1 here, it becomes q1 plus q2. Induction of minus q1 plus q2 here, so here it becomes q1 plus q2 plus q3, that you know, because the field in the meat of the conductor has to be 0. So now what we have, outer surfaces. So outer surfaces we have surface charge densities are same, that means q1 upon 4 pi r square is equal to q1 plus q2 upon 4 pi into 2r whole square, that is equal to q1 plus q2 plus q3 upon 4 pi into 3r whole square. So what we have, q1 would be equal to q1 plus q2 by 4, that is what you have, that is equal to q1 plus q2 plus q3 by 9. That is what I can write. So from this, if I have to, what we do, if we have to take the ratio of this, from here what we will have, q1 plus q2 is equal to 4q1, so q2 is thrice of q1. So from here it is 1:3, so 1:3 coming out as option B only. You can check for QB also. This is 1, this is 3, this will be, has to become 9 times, so this would be 5 times. So 1:3:5 you can go for. Next one. 2 satellites go around a planet P in circular orbits having radius 4r and r respectively. The speed of A is 3v, the speed of B. We know that orbital speed is proportional to this root r. So what I can write, VA upon VB is the root of RB upon RA, that is r by 4r, that is 1 by 2. So if VA is V, VB will come out, VA is 3v, VB comes out to be 6v. So go for option B. The nearer one will have the now the next. A person sitting on a chair in a satellite feels weightlessness because, you know, because it is in orbiting and the complete mg utilizes in your revolution and no normal force is needed, because normal is 0, therefore you feel the weightlessness. Earth is still attracting, normal force is not balancing because it is 0. Okay, and person is accelerated because in a satellite it is in a free fall, it is accelerated. Next one. The surface area of a black body is this and its temperature is this, the energy radiated by it per minute. So what we know that H, the energy radiated per unit time, is sigma A T ki power 4. This is per second. So in 1 minute you have to multiply it by 60 into H, that would be 60 seconds. So into 60 you need to do. Now what is sigma? 5.67 into 10 to the power minus 8. Area is 5 into 10 ki power minus 4. 727 plus 273, that is 1000 ki power 4, that will become 10 ki power 12 into 60. So what we have, this is minus 8 minus 4, 12 goes out, 60 into 5, 300 into 5.67 into 5.67. So what we have now, it would be 300 into 5, 5 3s are 15, and it would be something like greater, it would be 1.7 into 10 ki power 3 joule. That is what you can have it from here. Now the 15th, after 15, that is 16th. Carnot engine takes this much heat from a reservoir, so this is what I call as QH, and gives it to a sink. The work done by the engine is, so first of all what I can make out, QC by QH I know is equal to TC by TH. So what would be QC? QC I can directly make out, QH is 3 into 10 ki power 6 into TC, 27 means 300, 627 means it is 900. Okay, so this is 1 into 10 ki power 6. So definitely what the work done by the engine, is 1 minus QC by QH or 1 minus TC by TH. We could have direct done without calculating QC. I have calculated, no point, but you should directly do the QC by QH. So it comes out as 2 by 3. Okay, we were not asked to have the efficiency, no issue. The work done would be QH minus QC. I have done it slightly wrong. 2 into 10 ki power 6 calorie, and 2 if I convert it into 4.2, that is 8.4 into 10 to the power 6 joule. So go for option B. Read the question carefully, otherwise you will waste time like me. Next. Carnot cycle of a reversible heat engine consists of, you know, it is 2 isotherms and 2 adiabats. So look for that option, that is option C. That's an easy one for you. Galvanometer coil has a resistance of 50 ohm and the meter shows full scale deflection for 5 milliampere. For converting into 20 volt voltmeter, so initially what is the VG, what I write, that is IG into G, that is 5 into 10 to the power minus 3 into 50, that is I can write as 0.25 volt. So the factor by which it increases N would be 20 upon 0.25, that is 2000 by 25, that comes out as 80. So 80 times if you have to increase the what we apply here, what we apply a resistor in series, that is equal to G times N minus 1. So G is 50 into 79. So what we have, 5 9s are 45, 5 7s are 35, 3950 ohms in series with the galvanometer. Go for option A. Next one, a voltmeter having a resistance. This is connected to a cell of EMF internal resistance. Is the error in the measurement of the EMF. Now here this voltmeter is connected like this, okay, 2 ohms 2 volt. So here what would be the voltage measured by the voltmeter, or you can say the current, you can first of all say 2 upon 1000, that is 2 milliampere. So V measured would be equal to I into R of V, that is 2 milliampere into 998. So this is 2 into 0.998, 2 8s are 16, there is 2 9s are 18 and 1 what we have 18 and 1, that is 19, and here 19. So 1.996 volt. So the error is 0.004. So if I say the error would be 0.004 volts, that is equal to option C, that is the error. Instead of 2 it is measuring 1.996. Next, which of the following is false for a bar magnet? It doesn't produces magnetic field, it produces magnetic field, so it is false. So other you can check out. Next, two persons A and B start from the same location and walked around a square in opposite direction with constant speed. It has a side 60. A and B speeds are 4 and 2 respectively when they will meet for the first time. So see, like this. So both start from the same location. One goes like this, one goes like this. Okay, when will they meet for the first time? So for my take is, consider it as a 1D problem, and let's say because for they have to meet, the both will have to cover a total distance equal to the perimeter, which is equal to 240 meters. So one starts, A start with 4 and let's say B start with 2. So I can make out at what time they are going to meet. So for the time of meeting would be equal to the relative separation is 240, relative speed is 4 plus 2 6, that is 240 by 6, that is 40 seconds. So in 40 seconds this will cover 80 meters and that is going to cover 160 meters. So they will meet for 40 seconds. Okay, you have to only calculate the time, so 40 seconds you can directly do this. Next one, a body is thrown with a velocity 20 meter per second at an angle 60 with the horizontal. Find the time gap between the two positions of the body where the velocity makes an angle 30 degree with the horizontal. Okay, so it is something like this. This is thrown with 60, so 2 instant when it makes an angle 30 is 1 and 2, this and this. Okay, so first of all what I can make out, I can make 1030 is it would be a one time it would be plus 30, one time it would be minus 30. So I can write it like this, that would be equal to Vy by Vx, that is Uy minus Gt upon Ux. So what I can write it as plus minus root 3, that is Uy is 20 cos 30, that is equals to 20 sin 60, that is equals to 10 root 3 minus 10t, and this would be 10 20 cos 60. Okay, so 10 goes, it is root 3 minus t. So one time taking it as root 3, that would be the smaller time, that t comes out to be what we have, that t comes out to be, there's some issue, 1 by root 3. Okay, 1030 is not root 3. This was a very grave mistake I was doing. So first time it is 1 by root 3, so t comes out as root 3 minus 1 by root 3, and the second time this is t1, the t2 would be when it is minus 1 by root 3, so that would be root 3 plus 1 by root 3. So the gap would be, if I do the gap, t2 minus t1, so what I will have, 2 by root 3. So 2 upon 1.732. So now you can make it out, it would be 1 point and it would be 1.15. I think the closest one will be like this, not 1.5. So it is 1.15 second. Next, block of mass m lying on a rough horizontal plane is acted upon a horizontal force P and another force Q. Okay, the block will remain in equilibrium if the coefficient of friction between them is. So if I draw the FBD, I generally draw it like this. Better to draw like this. This is Q and this is P. So no confusion, and this angle is theta. So it has a tendency to go forward one would be normal, one would be mg, and that would be friction, Fs. We want to remain at equilibrium. So first of all, in vertical, N would be equal to Q cos theta plus mg, and for horizontal, P plus Q sin theta should be equal to Fs, and you know Fs should be less than equal to mu Sn, so P plus Q sin theta should be less than equals to mu s into N. N is Q cos theta plus mg, so mu s should be greater than equals to P plus Q sin theta upon mg plus Q cos theta. So what we have it, the first one seems to be the most appropriate one. Go for the option A. Next, here the important thing was normal is not mg, normal will be more because of the effect of this Q's vertical downward component. Now we have a brick of mass 2 kg just begins to slide down an incline when angle is 45 degree, that is repose angle. So what is the force of friction will be? So that is the repose angle. So at repose angle, that friction is mg sin theta, so mg sin 45 would be the value of the friction, that is 20 into, or not 20, sorry, 2 into 9.8 into 1 by root 2, that is 19.6 by root 2. Go for option A, you can try it. Next, 25th. Now when the nucleus of this uranium disintegrates to give nucleus of this uranium 82, uranium, how can uranium be 82? It should be lead, I suppose. The number of alpha particles emitted and beta. So first of all, change in mass number, 38 minus 6, that is 32. We know mass number changes only because of alpha, that is due to 4. So 32 by 4, that is 8 alpha. Because 8 alpha, 16 should be the decrease in Z. But here the decrease is only 10, that means 6 beta particles are needed to increase it. So this would be 8 and 6. I can go for 6 beta minus and 8 alpha. So go for option C. Next, distance in the free space at which intensity of 5 eV neutron beam reduces to half will be nearly. Okay, take the half-life to be 12.8. Okay, 5 eV neutron. So first of all, we have 5 eV neutron. You need to calculate the speed. So 5 into 1.6 into 10 to the power minus 19 is neutron mass. You take as approximately 1.6 into you take the mass as 1.6 into 10 to the power minus 19, I suppose. So that would be half 1.6 into 10 to the power minus 27 into v square. So v square approximately is 10 into what we have, 27 and 19, that would be 8. So v comes out as approximately, if I do it, is 10 to the power 4 into root 10 meter per second. Okay, now, or you can say it is 10 root to 10 kilometers per second, that would be better. Now the half-life is 12.8, so beam intensity will reduce in 12.8 minutes. So distance traveled would be 12.8 into 60 into 10 root 10. So what we have now, this is what we can write, 128 into 6, 6 8s are 48, 6 2s are 12, 16, 6 1s are 6, 768 into 10 root 10. So 7680 into root 10 is approximately 3 point something. So 768 into 3 times, that would be, if I do, that is approximately 3.14. so 8 3s are 24 and 7 3s are 21, 21 and 24 somewhere in between, so it would be 24,000 kilometers. That is what I can make it out from this given particular data. Okay, next, if a simple pendulum of length L has a maximum angular displacement alpha, then the maximum kinetic energy is. If it has a maximum angular displacement alpha, I can make out from the energy conservation, if this is alpha, so when it goes like this, the gain in kinetic energy would be mgl 1 minus cos alpha, that would be equal to half mv square. That is the maximum kinetic energy, that is mgl 1 minus cos alpha. So go for option C. Next, a particle suspended from a vertical spring oscillates 10 times per second. At the highest point of oscillation, the spring becomes unstretched. Find the speed when it is stretched by 0.10. Okay, it oscillates 10 times per second, so frequency you know is 1 upon 2 pi root of k by m. Okay, so it is 10 is 1 upon 2 pi, that is root k by m. This is the first thing that I've got. Now at the highest point it becomes unstretched. It becomes unstretched, that means that is the extreme, and we know the mean position x0 would be equal to mg by k. x0 would be mg by k, so that means amplitude is also equals to x0, that is for sure, because the unstretched point is the extreme, so mean and extreme gap, that is the amplitude. So find the speed when the spring is stretched by 0.2 centimeters. So this amplitude, first I solve it, it is m by k into g. What is m by k? M by k, if I write from there, this m by k things will come out to be 1 upon 20 pi square, and g is given as pi square. So this amplitude comes out as 1 upon 20 into 20, 1 upon 400, or what I can write it as, if I do this in meters, so in centimeters if I do, this will become 100 by 400, that is what we can write as 0.25. okay, that is what I can write, 0.25 centimeters. So when it is stretched by 0.2, that means at that times the displacement from mean position is 0.25 down, so 0.2 down it would be 0.05. so velocity you write as omega under root of a square minus x square using the SHM rules. So what is omega? Omega is 2 pi f, 2 pi f is 20 pi, a square is 0.25 square centimeter square minus x square, that is 0.05 square. So what we have now, we will have, keep it in centimeter per second only, so 0.25 square, 1 by 4, that is 1 by 16, 1 by 20, that is 1 by 400. So this is 20 pi, 400 common, 16, 25, and this is 24. So if I do, this is 6, this is 100, so this is 3, and this is 50, so root of 3 by 50. So 20 pi into root of 3 by 50. So 3 by 50 is approximately what we have 16, so 20 pi by 4 is what we have 5 pi, so it would be around 5 pi, so around 5 pi it would be 15.4. that is I can go for using my approximation styles. You could do in the way you like. Next, particle of charge moving with velocity along x-axis enters a region where the field of B along the y-axis, electric field along negative z. If the charge continues along the x-axis, the magnitude of B is. That means if it continues, all are perpendicular, so V should be equals to E by B, or B is equal to E by V. You can directly do, you have done many questions like that, because the magnetic force cancels the electrostatic force. So E was 10 ki power 4 and V is 10, so it comes out to be 10 to the power, what we have, this comes out as 10 to the power 3. I can say go for option A, which is very high magnetic field actually. If the uncertainty in the position of electron is this, that would be the value of the uncertainty in the momentum. So what we know, delta P into delta X should be greater than or equal to h by 2 pi. So the uncertainty in momentum would be h by 2 pi into delta X. So h is 6.63 into 10 to the power minus 34. 2 pi is 6.28 and delta X is 10 to the power minus 10. So it approximately 1 point something, and this would be 10 to the power minus 24. So okay, how much something, that is important. All are 10 to the power minus 24. Okay. So 6.28, it would be 1, and 63, 28, 63 and 28, what we have 35. So if I go 0.35, so what we'll have, so it is again 0, then 350 is 628, it would be 5 times. So it is 1.05 into 10 to the power minus 24. So go for option A now. Next, the density of the water at the surface of ocean is rho, bulk modulus is B, then the density of ocean water at depth when the pressure is alpha P naught, where P naught is, we know bulk modulus, the definition of the bulk modulus says minus delta P upon delta V by V. So what is the change in volume? First of all, what we can write it now, we can have this minus V upon delta V, the pressure changes alpha P naught minus P. So alpha P naught minus P naught, that is what I can write, that is equal to bulk modulus. Now, so the new volume, final volume would be equals to V minus delta V, because pressure has increased. So we have to just check the magnitude of the delta V. If I'm doing this, so magnitude of delta V is V minus V by beta into P naught. I take common, it is alpha minus 1, I can write. Okay, so what we have now, we have V 1 minus P naught alpha minus 1 by beta, that is what I can, beta or B or bulk modulus, you can write it like this. Now density would be inverse to volume. So what we have, rho final upon rho initial is V initial upon V final. So rho final would be, what I can write, V upon V final times rho initial, which was rho. So V upon V final, so that comes out as rho B upon 1 minus P naught alpha minus 1, that is what I can write. So going by the option, it would be option A. So go for option A in this particular case. Next, we have a rubber cord of density D, Young's modulus Y and length L, suspended vertically. If the cord extends by length 0.5 L under its own weight, then L. Now we know this formula, just remember this, because of its own weight it is called self elongation, is delta L is mgl upon 2ay. This is a direct result we get from integration, better to remember it. I always call my student to remember this. So 0.5 L is m here is density, what we have, d into volume AL into G into L upon 2AY. That is what I can write. So this was D. Okay, so this A goes, L and L goes, so the value of L comes out as, if I do this now, the value of the L in this particular case 2 into 0.5 would be 1, so Y upon dG. So this go for option B. This is the appropriate one here. Next, monochromatic beam of width T is incident at 45 degree on air water surface. The refractive index is mu. The width of the beam in water is. So what happened to the width of the beam? So let's see like this. This is how it is entering. Let's say like this. This width that we had, we talk of this perpendicular distance, this is T. This angles is what we are given as 45 degree. So when it enters at 45 degree, this is 1, this is mu. First of all, the Snell's law says 1 into sine 45 would be equal to mu into sine r. So sine r is going to be 1 upon root 2 mu. That is what we are going to write. Sine r is 1 upon root 2 mu for sure. So it definitely bend towards it like this, and this would be also like this. This is r, this is r. So if I draw the perpendicular now, this would be like this. This is T dash. So this is 45 degree that we had. So this angle was also 45, and this angle if I talk about this particular one, we know this is 90. This would be 90 minus r. So this would be r. I can write. So going by the data, what I can write in the above triangle, right triangle, what I can say, sine 45 degree is equals to T by this length, let's say AB, T upon AB. And in the lower one, what I can write is cos of r. Cos of r is equal to what I have, T dash upon AB. So if I divide both, cos r upon sine 45, that is what we get. What we get is we get it as T dash by T. So this T dash would be cos r. What sine r is 1 by root 2 mu, so cos r you would be root 2 mu, and if I do the square, this would be 2 mu square minus 1 under root. So 2 mu square minus 1 under root upon root 2 mu, and sine 45 is 1 by root 2, that cancelled, times T dash will be that times T. So it is root 2 mu square minus 1 upon mu into T. So go for option D. So it's a good question, very good question. Next, light is incident normally on the face AB of a prism as shown in the figure. Layer of liquid is applied on the face. If the prism is made of a glass of refractive index 3 by 2, then the limit of mu for which TIR takes place on face AC. So for TIR to take place, because we know this is 90, this is 60, this angle is 60 degree. So what we have, the theta C should be, in limiting case, is 60 degree. So theta C should be 60 degree, or you can say for the TIR to occur, theta C must be less than equal to 60 degree. That is what we can write. So sine theta C should be less than equal to 60. 60 means what we can write, root 3 by 2 sine 60. Sine theta C, definitely this would be denser to rarer. So rarer would be mu upon 3 by 2 should be less than equal to root 3 by 2. So mu should be less than equals to 3 root 3 by 4. That is what we are getting. So mu should be less than, or equality is generally avoided, so it's better mu is less than root 3 by 4, because in that case it goes almost grazing way. So it is option A we go for. Next, particle of mass m moves in the xy plane with a velocity v along a straight line AB. If the angular momentum with respect to origin is LA when it is at A and B, you know, when it travels on a straight line with a constant speed, the angular momentum about the point remains constant. Why? Because the line of action of velocity is same and its perpendicular distance from origin remains same. Whether it is at A, B or C, this R perpendicular remains same, so MVR perpendicular remains exactly the same value. This is a common concept asked many times. Next, sphere of mass m radius R rolls on a horizontal plate without slipping. Now it rolls up vertically the maximum height. So it is rolling up, so what we have, no loss in energy. So the total energy which we write it as half IP omega square, and IP for a sphere, taking it at solid, it would be 2 by 5 plus mr. So what we will have, it is 7 by 5 mr square into omega square would be u by r ka whole square, that would be equal to mgh. Directly you can do m and m goes, this r square goes, so 7u square by 10g, that is the h. This is the question I think we have done. Now again, to make you clear, I write this total kinetic energy as half, what we write is simply half I about what we say, I about the instantaneous IAOR, or what we can say the initial point with the point of contact, into omega square. Or you can also write it as half mv square into beta, and you know the beta for the solid sphere is equal to 7 by 5, 1 plus 2 by 5. Beta for ring is equal to 2, for disk is equal to 3 by 2. So these are the data that we commonly use. Next one, if we add impurity to a metal, then those atoms who deflect electrons, therefore we have done this also before, the electrical and thermal conductivities both will decrease because of the increased you can say number of collisions. So this is the question that has come before also. 38. To detect light of wavelength 500 nanometer, the photodiode must be fabricated. So to detect what we have, it should be equal to the band gap. So band gap value, that is hc by lambda, is approximately or around that band gap or greater than that band gap. So what we have, the minimum band gap, it should be greater than equal to this. So Eg should be less than equal to 1240 upon 500, that is EV. You can do, so 124 by 50 or 12.4 by 5, it would be what we have, 2.8, or what we have, yes, it would be 2.8 or 2.48, that is what we can make it out. It would be around 2.48 or 8. So this would be the minimum bandwidth, minimum band gap, I suppose, not bandwidth or gap, whatever you can write like. Next, during an experiment, an ideal gas is found to obey this law. The gas is initially at temperature T and V, and it expands to 2V. The resulting temperature is, so P square V is constant. P I can write it as nRT by V square into V is constant. So what we get, T square V to the power minus 1 is constant. So T square is proportional to V, or T is proportional to root V. So temperature is double, temperature will become root 2 times, simply using the ideal gas equation, nothing else. So the answer would be C1. So that's not tough for you, I suppose. Go for the next. The dimensions of the ratio of magnetic flux to the permeability is. Now, where you get the two results, this flux and this permeability. So if I do this, I can write it as magnetic flux, I can write it as B. B, let's say for a wire, is mu naught I by 2 pi r, you remember, into area. So the ratio of flux to mu naught, or mu, that is one and the same thing, that would be I A by R. I can make out. I is ampere, A is L2, R is L. So that comes out as AL minus 3. So going by this AL minus 3, go for what we have, sorry, A into L, not minus 3, A into L. So it would be option A. So you can do it like that. Next one. In the phenomena of diffraction of light, when blue light is used in the experiment instead of red light, what we have? We know the fringe width depend on lambda. So if blue light is used, lambda decreases, so fringe width will become narrower. You all know this. The same happens in YDSE also. The electric and magnetic fields associated with EM wave along z-axis, because it is z-axis, that means E cross B must be along z-axis and they should be perpendicular. So I cap J cap will suffice, K cap I cap not possible, J cross I minus K not possible, J cross K I not possible. So only option A is clear. Next one. A wave pulse on a string has the dimension shown in the diagram. The wave speed is 1 at point, if point O is a free end, the shape of the wave at time 3 seconds is okay. So first of all, this end will strike at 2 seconds, this end will strike at 3rd second. Okay, so at 3rd second it is about to strike, so it will remain at that amplitude. It is fixed end or free end? It is a free end, so that end will remain at the top, and this is about to come like this. This is the first one, and because it is reflected without any phase change, so it would be like this. It would be again going like this. So what we'll have, the previous ones and this one both will add up. So this one and this one both will add up, so 1 plus 1. So basically its slope will get doubled and this height will get 2 times. So it will be 2 centimeter. The slope will be getting doubled here. So as per the given option, it would be upwards, not downwards. So upwards we are given only 2 options, but the height is going to be doubled. So go for option B. That is simply you can do using the superposition. Next. An open organ pipe has a fundamental frequency of 300 Hz. The first overtone of a closed organ pipe has the same frequency as the first overtone of an open organ pipe. How long is closed organ pipe? Okay. So first overtone of a closed organ pipe, that would be 3V by 4L of closed, would be equal to, as the first overtone, that is 2V by 2L open. Okay. How long is the closed pipe? So L closed would be equal to, from here I can make out L closed would be equals to 3 by 4 of L naught. So it is 3 by 4 of L naught. And what is L naught? So for L naught, F naught, we use V by 2L, that is given as 300, V is given as 300, so 2L is equal to 1, so LC, sorry, so L closed is half, so 3 by 4 into half, so this is 3 by 8 meters, 3 by 8 meters, so 3 by 8 is approximately what we can write it as. So 3 by 8, that is 27.5. This is the answer as per me. 37.5, sorry. So 37.5 is the answer. No option is matching, so it's wrong. If I see their solution, they have taken it to be 330. So that is a mistake. So this is a bonus for you, I can suppose. Next, last one. A car of 1500 kg lifted up by a distance 30 meter by a crane and half meter. The second crane does the job in 1 minute. The ratio of their powers is, so because it takes double the time, that means the first one is 2 times more efficient, because that is energy per unit time. Energy is same. The first one is doing in half the time, so its power is double. So that was today's paper. Thanks for watching. Keep sharing the channel. Thank you once again.